The following graph shows the approximate value V of t of subprime normally classified as risky mortgage debt outstanding in the United States. Use the graph to estimate to one decimal place the average rate of change of V of t with respect to t over the interval 2, 6 and interpret the result. Over with 2-year periods was the average rate of change of V of t the least. For part A, to compute the rate of change, we will need to know the input and the output of the corresponding interval. For t equal 2, from inspection, we see that the value when t equal 2 is between 400 and 600 billion dollars, and so it is 500. The unit is again in billion dollars. When t equals 6, the value of subprime mortgage is 1200. Again, this is 1200 billion dollars in t equals 6. If the graph is given, we just simply go to t and go to the height and read off the y or vertical coordinate values. When t equals 6, we see that v is 1200. Having the 2 points, when t equal 2, v is 500, and when t equals 6, v is 1200, we can compute the average rate of change of v, and that is the ending amount 1200 minus the beginning amount 500 over 6 minus 2. This is the change in y over the change in x, or the change in the subprime debt outstanding over the change in year. The numerator is 700 and the denominator is 4. Remember that the unit in the numerator is in billions of dollars and the unit in the denominator is year. If we were to take 700 divided by 4, we will get 175, and again, this is 175 billion dollars per year. The unit on the top is billion dollars and the unit in the denominator is year. How do we interpret it? From the year 2002 to 2006, because when t equal 2, the corresponding year is 2002. The subprime, in this case, the V represent the value of a subprime mortgage debt outstanding in the United States. Since the rate is positive, we would use the term increase by $175 billion per year. Each year, the debt increases by this amount. In 4 years, the debt increases by 700 billion, so each year on average, $175 billion. Over with 2-year period was the average of change of V of t the least. One way to do this is just simply compute every consecutive 2-year period from 0 to 2, from 1 to 3, 2 to 4, 3 to 5, 4 to 6, 5 to 7, 6 to 8, and see which one is the smallest number. But using the graph, we see that the rate always increases because the value of the outstanding debt keeps increasing. We know that the average rate of change will give us the slope of the secant line, and with the slope, the steeper it is, the larger the rate. And so if we are interested in the least rate, we will simply look for the slope that is the least steep. all of these slopes are increasing, but we observe that the one with the smallest or the less steep is this one, the last 2 years from 2006 to 2008. And so our answer will be over the period 2006 to 2008. And again, in 2000 to 2002, the slope is steeper, a little bit steeper than the slope from 2006 to 2008. And the slope from 2004 to 2006 is steeper for sure, because we see that it had the higher or the larger increase in the height.